Now McKenna.
Today we're walking through example 5b4. So a homogeneous rectangular plate is released from rest with its upper surface being horizontal. Assume the pin at O to be smooth. What we're finding is determining the maximum angular velocity of the plate as it rotates about its pin support at O. 11-step process of finding the angular velocity of the plate. So with step 1, we have a free body diagram, our mass center G with the weight of the plate coming down. And then we have two reaction forces, Ry and Rx. Step 2, we're finding our coordinate system, which is just I and J. Step 3, we are writing all the forces in vector form. So with omega equaling negative mg in the J direction, Rx equaling Rx in the I direction, Ry equaling Ry in the J direction. Step 4, writing all the accelerations. So with this, we write the acceleration equation of AG equaling AGX in the I direction plus AGY in the J direction.
So in step 5, we gotta do the sum of forces around this center of mass. So with the equations that Max found in step 3 and 4, we write W plus Rx plus Ry equals mass times acceleration. We plug in the i's and j's of those equations, and then we write our two scalar equations. So we have our I direction and then our J direction. And then in step 6, we do our sum of moments around point A, or we can apply case 1 to this equation and get rid of this chunk of the equation. So case 1 is when point A is on the center of mass. So then we plug in all of the forces that'll make moments around the center mass equals this last part, and then we make another scalar equation in the k direction.
So with step 7, you have your mass table of at T1 and T2. At T1, 0, and at T2, you use the kinetic energy equation to plug in there. With step 8, use your weight table from V1 and V2. So if position 1 shown here, and position 2 shown here with the plate being rotated but keeping G in a line with point O. Keep in mind you have to always have a 0 reference point, which is this line here. Here we have H1 from the 0 reference line down to the an imaginary line extended out from G in position 1. H2 is from the 0 reference line down to where G is in position 2. And with these two little equations, you can solve for H1 and H2. And then step 9, your UNC from 1 to 2, you have everything else, which is your Rx and Ry, and both of those equal 0.
Now in step 10, we have to apply everything to the work energy equation, which is here. So based off the charts that Max drew up a couple steps ago, this is 0, and this is 0. It gives us this equation. But we don't have all the information that we need. We still need to find another equation to apply to the problem. So we have to do a step 11 and use an equation from chapter 2, which is this velocity equation, because it has the angular velocity that we're solving for. Then we solve for it, and it's in the I direction. So then we have to solve for the angular velocity, we have to plug the scalar equation 5 into the scalar equation 4, and that's what this is here. And then you just solve and set it equal, the angular velocity equal to everything else. And then plug in your numbers and you have your solution.